Hello students, so today we'll be discussing the chapter alcohols, phenols and ether. Okay, so first we'll look into the preparation of alcohols. Basically, alcohol is when you have OH group attached to an alkyl group. See, when you have OH attached to this alkyl group, you call it as an alcohol. So now this is an alcohol. Okay, that's a general representation. You need OH group. Okay. Now we'll look into the preparation of alcohols. So first one is the preparation of alcohols from alkenes. What are alkenes? Alkenes are compounds which have double bond, right? Alkene. So it will be having a double bond. So we'll be discussing how do you prepare alcohols from alkenes. Okay. So here the first method is from by acid-catalyzed hydration. Okay. So in acid-catalyzed hydration, what you do is the alkene is made to react with water in the presence of acid, then you get alcohol. Okay, so now this alkene can be symmetrical or unsymmetrical. Okay, if it is symmetrical, fine, it will the reaction will proceed, and if it is unsymmetrical, you have a confusion like how it is going to proceed. So if it is an unsymmetrical alkene, it will follow Markovnikov's rule. Okay, so in the case of unsymmetrical alkene, it will follow Markovnikov's rule. And what is Markovnikov's rule? Basically, the hydrogen will add to carbon which is having more number of hydrogen atoms. So here in this case, water, you can write water as H plus and OH minus, right? So this hydrogen will be this hydrogen will add to the carbon having more number of hydrogen atoms. So here you have two carbon atoms. See, to this double bond, this one carbon atom, the other carbon atom. So this hydrogen will attach to carbon having more number of carbon atoms, more number of hydrogen atoms, more number of hydrogen atoms. So basically this hydrogen will attach to this carbon. Okay, so OH will be in this side. Okay, so that is what you got, CH3 and here OH. Okay, so now we'll look into the mechanism. Okay, so mechanism, first step is the protonation of alkene to form carbocation. So what do you mean by protonation? Protonation means addition of H plus. See, you call H plus as proton, right? So protonation of alkene to form carbocation. So protonation is basically addition of H plus to alkene. Okay, so in the first step, so in this step what happens? First, this water and H plus will react to form H3O plus. So basically in water molecule, this oxygen has lone pair. So oxygen will give its lone pair to H plus to form H3O plus. So this water will be the lone pair on oxygen will be given to H plus to give H3O plus, one lone pair. Okay. Now this alkene will react with this H3O plus. Okay. So how does, so now we are discussing the mechanism. So we'll look how is it going to proceed. Okay. So here you have a double bond. Okay. In double bond you have electrons, right? Double bond, when you have double bond, so each bond is made of 2 electrons, right? So here this bond, so the electron from this bond will attack this hydrogen. Okay, so this arrow mark shows electron movement. Okay, so here this bond will attack, the electron from this bond attack this hydrogen. Okay, so what happens, this basically it will attack this H plus. So in this bond you have 2 electrons, right? So this electron will go back to oxygen. So oxygen, it had given its lone pair, right? That is why we gave it as positive. So now when it gets back its pair of electron, it forms like water. Okay, so now you don't have the positive charge. Okay, so this electron from this bond will attack this H plus, and then this bond, oxygen will take its electron pair. Now what do you get? Now you get a carbocation. See, when carbon has a positive charge, you call it as a carbocation. Okay, now you got RCH2 plus water. So this is a carbocation. Okay, in the step 2, what happens is nucleophilic attack. Wait, so in the previous step, what did we say? Protonation of alkene to form carbocation. So protonation of alkene. So what happens here into this? This is the alkene. Okay, into this we took a proton. So basically you are getting only H plus from this, right? H plus, not hydrogen, H plus. So protonation of alkene. So this alkene got protonated. So here this hydrogen, this H plus from H3O plus. That is what you got, RCH. Okay, so this is the proton which we got from H3O plus. Okay, so protonation of alkene to form carbocation. So this alkene got protonated to form this carbocation. Okay, since carbon has a positive charge, you call it as a carbocation. Okay, in the step 2, nucleophilic attack of water on carbocation. So here this is a carbocation, right? and here this water. So the lone pair present in the oxygen atom, it will attack the positive charge on this carbon. So what do you get? RCH2, CH2, OH. So here basically oxygen will be making usually 2 bonds, okay, and it will be having 2 lone pairs. So 2, 4, 6, 8. That is how the valency gets satisfied. Okay, now oxygen is giving one set of lone pair to this carbon which is having positive charge. So basically it is making use of this lone pair. That is the reason you keep a positive charge on this oxygen. Okay, so here this lone pair will attack the carbon having the positive charge, and you get this RCH2, CH2, OH2 plus. Okay, so nucleophilic attack of water. Nucleophilic attack of water. What do you mean by nucleophile? We know. What is a nucleophile? Nucleophile is something which loves nucleus, and it will be something, and a nucleophile will love the nucleus, and it will be something which is having negative charge or which is electron rich. So here the nucleophile is water. So nucleophile will have, so it will do a nucleophilic attack on this carbocation. Okay, to form this, and the step 3 is deprotonation to form alcohol. So deprotonation to form alcohol, here you can see water. Okay, the oxygen, the lone pair of oxygen will be again taking the H plus from this molecule, and then finally you get the product alcohol. So deprotonation, basically the H plus is what is getting removed. So deprotonation means removal of H plus. Okay, so H plus is removed, and so in the final product you just have OH. So since OH is there, you call it as alcohol. See, RCH2, CH2OH. OH is a functional group attached to this alkyl group, so it is alcohol. So this is how you prepare alcohols by acid-catalyzed hydration. So next we look into the preparation of alkenes by hydroboration oxidation. Okay, by hydroboration oxidation. So in this case, what we use as a reagent is diborane. Diborane is basically BH3 twice, or you write it as B2H6. So if you see B2H6 or if you see BH3 twice, that means remember it is a diborane. So when you see it with an alkene, remember hydroboration oxidation is taking place. Okay, so in this case what you need to remember, okay, so into this alkene you are adding a diborane. So what do you get? You get 3 molecules of alcohol and then BOH thrice. Okay, this is a reaction. Okay, so now we look into the mechanism. Okay, so here this is an alkene and here this is diborane. You just split it and write it as HBH2 twice. Okay, so here what you need to remember is that in the case of HBr, see, when we told it as HBr, how did we write? We wrote it as H plus and Br minus, right? That was how we wrote there. So at that time it was H plus and Br minus, but in this case, so here it was proton, right? Proton was released. It is H plus, okay, but here it is H minus. In the case of diborane, hydride is being released. What is the reason? Because boron actually is electron deficient. So basically BH2 will act as like a something which is which gets attracted towards electron. Basically it will act as an electrophile because it is electron deficient. So what is an electrophile? Electrophile is something which will have a positive charge or which is electron deficient. So basically it will attack a place which is electron rich, right? So basically in this case BH2 is electron deficient, okay, and this H will be hydride ion. Okay, so this will be having a negative charge and this will be having a slightly positive character. Positive character in the sense it is electron deficient. That is the reason I told it is having a positive character. Okay, so basically this is hydride ion. So this will become like hydride ion and BH2. BH2 here, boron having an electropositive character because it's electron deficient. Okay, so this is how you write. Okay, H minus BH2. Okay, BH2 electron deficient. So in this case, how do you see when you can break a double bond, right? So I told you like you need to give positive charge in such a way that it forms a stable carbocation. So in this case, you can write it as like CH3, CH2, positive and here negative. This is more stable, right? So into this, this hydride ion will be attaching, okay, and into this place BH2 will be attached. So basically to the positive charge H minus will attach and to the negative charge BH2 will attach. That is what happened. Okay, here hydrogen got attached and here BH2 got attached. Okay. Again another molecule of alkene. Okay. Again another molecule of alkene. Here basically it is 3. Okay. So again another molecule of alkene will be reacting. So what do you get? Again the same process. Here you have HBH2. So you can write this BH2 as HBHR. Okay. Again from this you can split it as H and BH. Right. So here hydride will attack this position and then the rest BH will attach this position. Okay. So this is how you got it in this way. CH3, CH2, CH2 twice BH. See, you can write this in this format. If you didn't understand what is written over here, how you got it as twice, you can look into this. Okay, here what you got, CH3, CH2, CH2, okay, and then HBH. Okay, so in this product, then again to this BH, CH2, CH2, CH3 will be attached. Basically, this is what I wrote it over here. This is how the structure will look like. Okay. Again, what happens? Again, another molecule of alkene will react. Then what would happen? Again, into this molecule, you will have again one CH3, CH2, CH2 thrice boron. Okay. So it forms trialkyl borane. And then it will react with water, H2O2, NaOH, and you get alcohol, CH3, CH2OH plus BOH thrice. Okay. This also it forms trialkyl borane. Basically, mechanism. I hope you understood the mechanism. All what you have to do is that there will be 3 molecules of alkene. 3 molecules will be of alkene will be reacting with diborane to form 3 molecules of alcohol. Okay. So in the first step, when first molecule of alkene will be reacting with HBH2, you have to split it as H and BH2. Okay. And then basically BH2 will be attaching this carbon atom. BH2 will be attaching the carbon having greater number of hydrogens. Okay. So it will attach to this carbon and hydrogen to this carbon. Okay. Again another molecule of alkene will react. Again what would happen? In this now you have BH2, H and BH. So now to this here BH will come and attach and here hydrogen. So here basically you will have BH, then the whole group, this whole group, and then one hydrogen will attach to this position. Okay. That is how you got it as CH3, CH2, CH2 twice BH. Again, another molecule of alkene will be reacting. So what would happen? Again, here you can write it as H and Br2. Okay. So now this H will be attaching to this carbon and this Br2 will be attaching this carbon. So here you have boron and the whole set. Okay. So that is how. So here basically that will be like, to this you have CH2, CH2. You don't have hydrogen. So basically this molecule is basically what I wrote it as trialkyl borane. Okay. And then it reacts with water and hydrogen peroxide in the presence of NaOH, you get alcohol. So this is how you prepare alcohols by hydroboration, oxidation. I hope this is clear. So now let us look at the preparation of alcohols from carbonyl compounds. Okay. So basically what are carbonyl compounds? Carbonyl compounds are compounds which have C double bond O. So if a compound has C double bond O, you call them as carbonyl compounds. Okay. Then by reduction of carbonyl compounds, what is reduction? Reduction is basically addition of hydrogen or removal of oxygen or gain of electrons. Okay. So in this case, reduction means addition of hydrogen. So basically addition of hydrogen or removal of oxygen or gain of electrons. Okay. You say, then you call them as reduction. Okay. So in this case, reduction means addition of hydrogen. Okay. So by reduction of aldehyde, aldehyde is also a carbonyl compound. Okay. We were discussing by reduction of carbonyl compound. So aldehyde is a carbonyl compound. So aldehyde, basically the functional group is C double bond OH. So when you see C double bond OH, then it is an aldehyde group. Okay. C double bond O, then H. Then it is aldehyde. Okay. So by reduction of aldehyde, so here RCHO plus H2 in the presence of palladium, nickel, platinum, you get alcohol. Okay. So here this is the aldehyde. Here you pass hydrogen. Okay, hydrogen H2. Then the catalyst. Catalyst you can use palladium or nickel or platinum. Okay. So when you pass hydrogen in the presence of this catalyst, then you get alcohol. Okay, see, you can see a OH group, so it is alcohol. So aldehyde, in the presence of hydrogen, in the presence of catalyst, you get RCH2OH, which is alcohol. Okay, then you can look at one example. Basically, R group is an alkyl group. So when you consider R as CH3, then this becomes acetaldehyde. CH3CHO is acetaldehyde. Okay. The other way is you can use lithium aluminium hydrate or sodium borohydrate. Okay, LiLH4 or NaBH4. These are basically reducing agents. Okay, they give H minus hydride ion. See, when you say acid, usually when you say acid, the concept is it will be releasing H plus ions, right? When you say HCl, it will be releasing H plus, right? In the same case, in this case, LiLH4, it will be giving hydride ion, which is H minus. Okay, so here either you can pass hydrogen in the presence of catalyst for this reduction, or you can what you can do is you can use reducing agents like LiLH4 or NaBH4. Then you get alcohol. Okay, so you can see here we used acetaldehyde, so we got primary alcohol, which is here we got as ethanol. Since we used acetaldehyde, you got ethanol. Okay, so which is a primary alcohol. Then second, we can look into the reduction by ketones. Ketone, it is also carbonyl compound. Its formula will be RC double bond OR. RC double bond OR. Okay, so here R and R dash, which are two different alkyl groups. Okay, you pass hydrogen, the presence of same palladium, nickel or platinum, any of the catalyst, then you get alcohol. Here you can see it is a secondary alcohol. Okay, and here you see an example. We write with an example, basically acetone, this acetone. Also in the case of ketones, you can see LiLH4 and NaBH4, you get isopropyl alcohol, secondary alcohol. So in these, by reduction of aldehyde and ketone, you can see either you can pass hydrogen in the presence of a catalyst, then you get alcohol, or what you can do is you can use reducing agents like LiLH4 or NaBH4. These are basically hydride hydride is released. Okay, so lithium aluminium hydride or sodium borohydride. Okay, lithium aluminium hydride or sodium borohydride, that is what is LiLH4 and NaBH4. Okay, so these are the two ways. So now you can notice one thing, this acetaldehyde, which is aldehyde C double bond OH, that is aldehyde. So when you use aldehyde, what you get is primary alcohol. Okay, you know already what is a primary alcohol. When OH is attached to a carbon, which is attached to just one carbon, you call it as primary. So when you do the reduction of aldehyde, what you get is primary alcohol. But when you do the reduction of ketone, which is C double bond O, RC double bond OR. Okay, RC double bond OR. When you do the reduction of ketone, what you get is secondary alcohol. What is secondary alcohol? OH attached to carbon, that carbon in turn attached to other carbon atoms. See, which attached to carbon, this carbon attached to two carbon. So here you get secondary alcohol. So you need to know this difference. When you reduce aldehyde, what you get is primary alcohol, and when you reduce ketone, you get secondary alcohol. And how can you reduce it? Either you can use hydrogen and in presence of catalyst, or you can use lithium aluminium hydride or sodium borohydride. Okay. Then third thing is by reduction of carboxylic acid. Carboxylic acid is basically C double bond OH. Okay, when you have this carbonyl, see all these are carbonyl compounds. Carbonyl compounds will be having C double bond O. Okay, C double bond O, then OH, then you call it as carboxylic acid. So RCOH in the presence of LiLH4, reducing agent, and then you pass water, and what you get is alcohol. Okay, this is one way of reducing carboxylic acid. Okay, using lithium aluminium hydride. And then second way is what you can do is this is basically acetic acid. CH3COH is acetic acid. First you pass methanol in presence of H plus, what you get is ester, and then you pass hydrogen, and hydrogen in the presence of a catalyst, what you get is alcohol. Okay, so here ester is also carbonyl compound. Ester, what you can see is C double bond OR. So when you have this functional group C double bond OR, it is ester. Okay, so in order to reduce ester, you use hydrogen and catalyst, hydrogen presence of catalyst. Okay, so this is acetic acid. So you need to know like what is an aldehyde. Carbonyl compound is basically C double bond O, you know that, and on the functional group of aldehyde, ketone, carboxylic acid, ester, you need to know the difference. You need to know what will be the product of it. See, CH3CHO aldehyde, we call it as acetaldehyde. Okay, here it is RC double bond OR, ketone is RC double bond OR. Okay, here one example is acetone. When CH3 C double bond O CH3, acetone. Okay, then when you have COH, this is an acid carboxylic acid group. CH attached to it, you call it as acetic acid. So you must be knowing the difference of it. So that's it. So now let us look at the preparation of alcohols from Grignard reagent. Okay. So basically, what is Grignard reagent? Grignard reagent is basically R and GX. Okay. So R is the alkyl group, then Mg, magnesium, X halide. Okay. So when you say Grignard reagent, what you need to think is it is RMGX. It is of the format RMGX. Okay. So now we will be preparing alcohol from Grignard reagent. Okay. By treating it with aldehydes and ketones. Okay. So basically, you treat RMGX with an carbonyl compound. Basically, here we will be discussing it with aldehydes and ketones. Okay, I have already told you aldehydes and ketones are carbonyl compounds. Carbonyl compounds basically will be having C double bond. Okay, so here we will be learning the reaction of Grignard reagent with aldehydes and ketones. Okay, so here RMGX. So basically, a charge separation. Here you can see that Mg, magnesium, it will be having a more electropositive character, and R will be having a more electronegative character. So here you can see, you can write it as R minus and Mg plus. Okay, so in this case and then this R minus will be attacking the carbonyl carbon. Okay, so basically it is a nucleophilic addition of RMGX to carbonyl group to form adduct. So we know what is a nucleophile. Nucleophile is something which has an attraction towards a positive center. Nucleophile basically represent it as Nu minus. Okay, right. And what is nucleophile? Nucleophile is something which loves the nucleus. So basically, it will have an attraction towards the electropositive centers. Okay, so itself it will be negatively charged. So here it is R minus. Okay, so it will be negatively charged. So it will be attacking a nucleophilic center. Okay, basically here this carbon is basically it will act as a nucleophilic center. What is the reason? Because it is carbonyl carbon. So here you can see a charge separation will take place. So this carbon will be having a electropositive character, and here oxygen will be having more electronegative character, right? So due to this reason, this carbon will have a electropositive character. Basically, it will act as a nucleophilic center. So due to this reason, there will be nucleophilic addition of R minus into the nucleophilic addition of RMGX to carbonyl group. Okay, so nucleophilic addition, because R is a nucleophile. Okay, nucleophilic addition of RMGX to carbonyl carbon to form adduct. So this is the adduct. So here R minus attacks this carbonyl carbon, and here this bond will shift to oxygen. So you get oxygen as O minus, and then this Mg plus X will join at this place. Okay, and then you do the hydrolysis. Hydrolysis, what is hydrolysis? Hydrolysis is basically addition of water. Okay, so you add water, and what you get here, it forms OH. Okay, so what you get is alcohol. Alcohol basically, when you have OH attached to this, you call it as alcohol, right? Okay, when you have the functional group as OH, you call alcohol. And then okay, so second step is the hydrolysis of adduct. Okay, so you must be knowing, like for example, in carboxylic acid it was C double bond OH. Okay, so this was here also you have OH, but this is carboxylic acid. Okay, so you must be knowing the functional groups. So here OH attached to carbonyl carbon, this is acid. Okay, this is carboxylic acid, but here this OH is the alcohol. So you need to know the difference. Okay, when I say when OH is attached to this alcohol, you need to know which, in this case it is alcohol. When OH is attached to carbonyl carbon, it is acid. Okay, and then next is so we'll look into the few examples. Okay, now first we discuss the mechanism, now we'll look at the examples. So in this case, formaldehyde, you know, aldehyde is basically C double bond OH. Okay, here you have R group, here R is H, hydrogen basically. So this is formaldehyde. So in this case, basically R minus will be attacking this carbonyl carbon. What you get at the end is alcohol, and this is primary alcohol. Okay, and second case is aldehyde. Basically this R in R. Okay, here it is not hydrogen. Basically you will have an alkyl group. In this case, aldehyde, C double bond OH group. So this is aldehyde. Okay, so in this case, when this R is hydrogen, called as formaldehyde. Okay, now in this case it is R. Okay, R meaning alkyl group. Okay, so here R minus will be attacking this carbonyl carbon, and you can see an adduct is formed, and then into this OH is attached. Okay, by hydrolysis OH gets attached. So here you get secondary alcohol. Okay, the third case, similar case, basically ketone. Ketone, I told you, it is RC double bond OR. Okay, this carbonyl group, and both sides you have alkyl groups. Okay, so here R minus will be attacking the carbonyl carbon, and what you get at the end is and alcohol. So in these three cases what you get is alcohol. But what is the difference? In the first case you get a primary alcohol, second case you get a secondary alcohol, third case you get a tertiary alcohol. So what you need to remember is that when you have a Grignard reagent as a reagent, and then what is the reactant you need to remember. If it is formaldehyde, Hc double bond OH. Okay, when you have formaldehyde, then what you get is primary alcohol, OH attached to one carbon, which in turn attached to one carbon. Okay, whereas if it is aldehyde, basically it is not hydrogen, C double bond OH, to it alkyl group is attached, basically Rc double bond OH. Okay, so when it is an aldehyde, what you get, aldehyde other than formaldehyde, basically what you get is secondary alcohol, okay, which attached to carbon attached to two other carbons. And when it is ketone, what you get is tertiary alcohol. So you need to remember this. When it is formaldehyde, you get primary alcohol, and when you get aldehyde, you get secondary alcohol, and when it is ketone, what you get is tertiary alcohol. So by the reactant, you must be able to identify what type of alcohol you get, primary, secondary or tertiary. Okay, that's it. Thank you.